Space. The final frontier. Come with us as we explore and unravel the mysteries of what lies beyond our planet Earth. Strap yourself in. Get your spacesuits ready as we prepare for takeoff in T-minus 5, 4, 3, 2, 1. Welcome to Inside Outer Space. Moon. Quick, look at the night sky. What's the most striking celestial object at night? It's of course the moon. The moon is a natural satellite to our Earth, which means it's a natural occurring object that orbits around our planet because of gravity. There are of course other moons, which are natural occurring satellites to other planets as well. Some planets even have more than one moon, like Mars and Jupiter. But let's talk about our own moon. The moon takes its name from moon, which was derived from Monet, a developed form of Mona, which was the term used in the Old English language. Sometimes the moon is also referred to as Luna, especially with regard to other moons. Luna specifically refers to the Earth's moon. The word Luna itself was derived from the Latin term for moon. The Earth's moon has an orbital distance of 384,400 kilometers, or 238,855 miles, which is about 30 times the diameter of Earth. The moon has a solid iron-rich inner core, covered in a liquid iron outer core. Around the core is a partially molten mantle made of magma, then finally the crust. Researchers theorize that the Earth's moon may have formed 4.51 billion years ago, just slightly ahead after Earth's formation. The most widely accepted theory is that the moon was formed from the remaining space debris left by a giant impact between Earth and Theia, a large celestial body that is close in size to Mars. With regard to Earth's rotation, the moon is synchronous with it. This means that when viewed from Earth, the moon always appears on the same side or face. Next to the sun, the moon is the next brightest celestial object seen on Earth. But the moon actually does not give off light. It only appears bright at night because of the light that it reflects from the sun. The moon has phases, as observed from Earth. This is because at different points in time, some of the sun's light is partially blocked, so a shadow is cast on the moon. This is why, from the Earth's perspective, the moon may appear crescent, half, or full. Since ancient times, people have learned to study and track the phases of the moon. This recording and tracking of the moon forms the basis of early astronomy and is instrumental in many fields such as agriculture, fisheries, navigation, and is also a basis for early calendars. The moon also is responsible for causing tides, as its close proximity to the Earth allows it to influence its own gravity on the Earth's waters. Solar flares. The Sun. A star that is at the very center of the solar system. It gives us warmth and light. But did you know that within it are countless physical and chemical processes that fuel the energy of the sun? Observe this. That looks like a large explosion on the surface of the sun. It almost looks like the flames of a wildfire. What you are looking at right now is what's known as a solar flare. Solar flares are sudden flashes of brightness that can be observed near the sun's surface. And it's not just a light flash. Solar flares emit a wide variety of emissions covering a very broad spectrum of energy. Let's take a look. The energy released in a solar flare is typically 1 × 10 to the 20th power joule. That's 1 followed by 20 zeros. For comparison, that amount of energy is millions of times stronger than a volcanic eruption. But that's just the typical solar flare. A major solar flare event can go up to 1 × 10 to the 25th power joules, roughly the equivalent of 1 billion megatons of TNT. Solar flares also eject clouds of particles in space, which includes ions and atoms. Sometimes, these clouds reach Earth after a day or two of the solar flare event. Solar flares also occurs in other stars, but the term used is stellar flares. So how does one occur? Solar flares occur when sped-up charged particles, mainly electrons, interact with the plasma of the sun. The acceleration is caused by the phenomenon of magnetic reconnection. When this happens, a large amount of energy is released, which causes an eruption of energy emissions. How do these affect the Earth? Well, solar flares have great influence over local space weather near the vicinity of Earth. Solar flare emissions of energy also produce a solar wind that can impact the Earth's magnetosphere, which carries harmful radiation, especially to spacecraft and the astronauts in it. Stronger solar flares can sometimes cause a coronal mass ejection, or CME, which are known to cause massive interference and even disable radio satellites and power grids on Earth, causing blackouts. The influx of X-rays within solar flares can also cause the ionization of the atmosphere and interfere with short radio waves of Earth, causing signal breakdowns for Earth's local communication devices. Mars, the fourth planet from the Sun, now coming in with a diameter of 6,792 kilometers or 4,220 miles and a mass of 6.42 × 10 to the 24th power kilogram or 1.409 × 10 to the 24th power pounds, with 2 moons, namely Phobos and Deimos, and an orbit period of 687 days. Its surface temperature is a cold -153 degrees degrees Celsius to a cool 20 degrees Celsius, or negative 243 degrees Fahrenheit to 68 degrees Fahrenheit. The second smallest planet in the solar system and known famously as the Red Planet. Welcome to Mars. Mars takes its name from the Roman god of war. The association with the god of war comes from the fact that Mars has a bloody red color. And it's not just the Greeks and Romans. Other ancient cultures also associate Mars with its redness. Ancient Chinese astronomers called Mars the fire star, while Egyptian priests simply referred to it as the Red One. Mars's redness is actually due to a large amount of iron in its soil. Despite its redness though, Mars is actually cold, being 228.5 million kilometers or 141.6 million miles away from the Sun. Its surface is rocky and full of canyons, craters, mountains, and all sorts of formations. Scientists describe Mars as dusty, and in fact, this dust covers all of Mars. Dust storms caused by the wind in Mars is very common throughout the year. But how do we know all of this about Mars? Well, humans have been sending probes and satellites to Mars for a long time now. It was in 1965 when Mariner 4, a NASA spacecraft, first passed by Mars. In 1976, NASA successfully landed Viking 1 and Viking 2, making it the first Earth spacecraft to land on the surface of Mars. We have since been regularly sending space missions to Mars to gather more information about our solar system neighbor. In a few years' time, sending manned space missions to Mars are the next steps being carefully planned by scientists at NASA. And who knows, maybe Earthlings will be visiting and even living on Mars in the future. Quasar. What's the brightest thing in space? The Sun perhaps? The Moon? Or maybe other stars? If you guessed any of these, well, you're almost right. But what if I told you that there are objects in outer space far more brighter than stars? They are known as quasars, short for quasi-stellar objects. Quasars are very distant objects which are powered by black holes that have a mass billions of times more than our own Sun. Quasars were first discovered during the 1930s by a physicist named Carl Jansky, who worked for Bell Telephone Industries. He discovered that there was static interference on phone lines crossing the Atlantic and deduced that interference may have been coming as waves emitted by the Milky Way galaxy. In the 1950s, astronomers by now have been using radio telescopes, which pair radio signals and visuals while looking at the stars. During this time, however, scientists noticed that some objects observed did not match. They refer to these as quasi-stellar radio sources for lack of a better term because they did not know at the time what they were. It would take another few years before astronomers deduce that these objects were not stars, but are actually bodies that are created as a result of particles being accelerated at the speed of light. Recently, scientists suspect that these tiny bright glimmers from distant outer space are signals coming from galactic nuclei. Quasars come from supermassive black holes. A supermassive black hole is a black hole that has a mass billions of times more than the mass of the Sun. Although light cannot escape black holes, some signals are able to break free from its edges and are accelerated near the speed of light. Most of the quasars observed are found to be billions of light years away from Earth. Since they are very far away, The light that can be observed from Earth are actually from an earlier point in time of the universe. So the more we observe far-off quasars, the more we get insights into what outer space was like billions of years ago. Scientists theorize that our very own Milky Way galaxy may have been a host to a quasar from way back at an earlier point in time. Quasars emit lots of energies. This energy can exceed billions, even trillions of electron volts. In fact, this energy is stronger than the combined energy of all the stars in our galaxy. And they are 10 to 100,000 times brighter than any star in the Milky Way. Hubble. Did you know how scientists take pictures of space? Well, some of the best pictures of space from the last 20 years were taken with a special satellite. Enter the Hubble Space Telescope. The Hubble Space Telescope, or HST, is a man-made satellite space telescope that was launched into low Earth orbit in 1990. And it has been in operation since. Although not the first space telescope, the HST is one of the largest and most versatile. It is considered as a vital research tool for astronomy. The Hubble is equipped with 4 main instruments that is used to observe near ultraviolet, the visible, and the infrared spectra of light in space. Hubble's orbit is just above the Earth's atmosphere, thus freeing it from the distortion caused by Earth's dust clouds and pollution. This allows the Hubble to take high-resolution images with low background light. Let's take a look at a couple of images taken by the HST. The Hubble is named after American scientist Edwin Hubble, who in the 1920s operated the largest telescopes of the time at Mount Wilson Observatory in California. The Hubble initially weighed 10,886.217 kilograms or 24,000 pounds and has gained an additional 1,360.777 kilograms or 3,000 pounds because of additional hardware fitted up until 2009. It also has a length of 13.3 meters or 43 feet, which is about as long as a large school bus. It can be found at the low orbit of Earth with an altitude of 547 kilometers or 339 miles above the Earth. Since its launch in April 24, 1990, the Hubble has made more than 1.3 million observations, which helps scientists obtain data for over 14,000 published scientific papers. The Hubble does not travel anywhere else. Its only movement is around the suborbit of Earth. It moves at about 27,359 kilometers per hour or 17,000 miles per hour. The HST also has no thrusters. It moves by using the principle of the third law of motion. It has wheels that spin in the opposite direction that it's going. While the Hubble is near Earth, It has observed and taken pictures of places as far as 13.4 billion light-years away from Earth. And the whole of the Hubble archive can be summed to about 140 terabytes. Neil Armstrong. One small step for man, one giant leap for mankind. These were the immortal words that one Neil Armstrong quipped as he became the first person ever to walk on the moon as the commander of the Apollo 11 spacecraft. Neil Armstrong was born in Ohio on August 5th of 1930. He had his start as a naval aviator in the years of 1949 to 1952. In 1955, Armstrong joined the NACA, or the National Advisory Committee for Aeronautics, as an engineer and test pilot. As a side note, NACA eventually became NASA. Armstrong became a research pilot for many of NASA's developmental projects. He is also known to have flown over 200 types of aircrafts. In 1962, Armstrong officially became an astronaut. 4 years in, he successfully became the first person to perform docking for 2 vehicles in space. Finally, in 1969, he became the first person to step on the moon, following the successful launch of the Apollo 11 along with his team, fellow space pioneers Buzz Aldrin and Michael Collins. Armstrong's career at NASA continued after the Apollo 11 mission, as he became the Deputy Associate Administrator for Aeronautics of NASA. He also became a professor in the 1970s at the University of Cincinnati and was chairman of Computer Technologies for Aviation Incorporated in Charlottesville. Throughout his lifetime, Armstrong has received many academic awards and special honors, including countless honorary degrees from prestigious universities, a Presidential Medal of Freedom, and the Congressional Gold Medal, to name a few. Neil Armstrong passed away on August 25, 2012 at the age of 82, but is fondly remembered for his contribution to space exploration and research. And that was another interstellar trip across the universe. Remember to join us next time for another mission to the cosmos and beyond. Only on Inside Outer Space.